Hello, Professor Colin. Today I take this opportunity to complete my video final examination of statistical course. Let me share my screen. So slide one, my name Hamdan Syed. Course title is MBA Statistics for Data Analysis and Visualization. Presentation title is MBA 6103 Final Exam and today's date. So content requirement is introduction, data analysis on the data set, statistical testing on my data set, modeling and interpretation, comparison of R and JASP, and final conclusion. Next slide. Introduction. So I'm using the assignment or 12 using the data of 400 Californian elementary school on their API index for 2000 data set uh, in the scale of 200 to 1000 to a composite score, including overall academic performance, which interacts with some of the attributes like the class size, year round, and uh, and year round, and parents with having some level of education or highest level of education. So we're going to see some variables and in interrelationship in this presentation. And I'm going to use using the R and JAS, some of the tools like correlation, flex plot, linear regression, model summary, ANOVA, coefficient. These are the tools I'll be using. Next slide. So explanatory on the data. So as you can see, this is a snap of my JASP using the raw data set. So in this data set, it shows all the variable, and on the right hand side, it shows the correlate using the JASP tools, what we are going to do, like a correlation, linear regression, and flex plot. So using this data, the correlation, keeping API and the year round on some college, you can see in this data set by using JASP, I have a negative uh, correlation, and I also have a positive correlation between the year round and some college. So basically, when the R is less than 0.25, that means it's a better, it has a larger effect size. And it also shows the different scatter plot. So you can see based on the API year round and some college, it shows the bar graph with density, and it shows the linearity of the curve, and it shows the another a variable or a factor that shows a decline trend, and some colleges have an up inclined trend with this, also shows the scatter plot in between the relationship. Next slide. Statistical testing on my data set. So you can see we're going to use the linear regression in ANOVA. We're keeping the dependent variable as the API, which is the average performance index, as my dependent variable. My continuous variable will be parents with a higher level of education from some college, and the factorial variable will be year round. In the model, we are going to have four different models. With the M0 will be the null model, M1 will be the year round, and some college will be M2, and factorial will be the M between some college and year round, which you'll be seeing in the next slide. So by using this, so my analysis that shows for the model summary, ANOVA, and the coefficient. So the model summary for all the four models. So as I explained, M0 is a null model. M1, which shows it is less than 0.25, which means it's a better effect size. And you can see the change of the percentage, like 22% for the M1, 3.1% for the M2, and 2.6% for the M3. So which is P is less than 0.05. That means it's a better fit model. It's highly significant. Where for ANOVA, you can see P clearly shows less than 0.05, which is highly significant, with the degree of freedom and the F value as a factor that shows for each model in the regression. Coefficient. In coefficient, also it shows for each and every model how gradually the p-value and the t-set, unstandardized and standard errors, which provides the value for their mean. Scatter plot. So we use the flex plot, keeping our x-axis as some parents which having highest level of education in some colleges. Have API 0 is our y-axis, and doing 2 factorial variable. One is no and one is yes. So you can see for the no, year and no, that shows the linearity of the curve, which has an uptick, but not as higher uptick as year-round yes, which shows a very much steep in this area. And the next will be from the linear regression. We also have a plot, ggplot. It's a residual versus predict value, and the theoretical versus observed quantity. So you can see the pattern of the scatter plot is like a funnel type plot, and in the QQ plot, it shows how the graph got populated. Majority of them fall within the line, and there are some flyers out at the beginning and the end. So FlexPlot revealed the similar pattern between some college and API. For schools that were open year-round, the FlexPlots revealed the increase of the percentage of parents whose highest level of education in some college has increased the academic performance. A similar trend with a steeper increase was observed in school open year-round. And for model assumption where tested value, the residual where fitted plot shows the linearity assumption was met, but indicated a violation as the residual exhibited with a funnel type pattern. On the QQ plot, that normality assumption was met, and the majority of residual were along the normality line. Next slide is comparison of R and JASP. R and JASP. So both R and JASP faces challenges with scale when dealing with a large data set. Although JASP has limitation and more pronounced to be the inability to access or modifying the R code. For R, it has a steep learning curve for the beginners. JASP focus on graphically use interface and statistical analysis more accessible. JASP strength lies for Bayesian analysis, but it lacks the flexibility in the data handling and can restrict for more advanced or complex. So ultimately, between JASP and R, it's a user needs where benefit for R flexibility power against ease of GUI-based interface observed. I personally show one of the example in a different data set where I have in JASP, I have a wide range of variable data sets, but I could take that variable data set, I could shrink into a factorial variable. So I could write by using an R code, and I was able to restrict the grad school variable to limit it, and I could plot it. So in the plot, it clearly shows where my x-axis is the grad school factorial and the y-axis is the API. And you can see the increase in that factor as it goes from each and every phase of the grad school. So conclusion. So based on the data set what I used, hierarchical regression reveals and explains the highest proportion of variation in school, and it provides the R squared value. So adding each and every variable that shows the model has increased with a certain 3.1%, and for factorial sum school times year round, it shows the increase by 28%. And in ANOVA table that shows in the hierarchical regression where statistical significant at each step, where p-value is less than 0.05, which is highly significant, and coefficient table also has a significant impact, especially for year-round had a greater impact on the API. So 1 unit increase the percent of education level in some college increased by 1.41 units. So additionally, a significant interaction was found between some college and year-round. Unstandardized coefficient was 5.99 to a p, which is less than 0.001. So the synergies between the EDA, statistical and modeling is crucial for driving effective and impactful decision making in domain. EDA provides the foundation for understanding data, statistical testing validates insights and assumption, and predictive model empowers proactive decision making based on future forecast. Ignoring these steps can lead to a costly mistake and hinder the innovation. That pretty much closed my final exam, Dr. Colin. Thank you for everything. Really appreciate and thanks for being patient with me. Thank you.